In the last video, I introduced you to the notion of a conjugate pair within complex numbers. And we're going to take that a little bit further now as we look at some problems involving equations and conjugates. So take a look at this example. We want to find a quadratic equation that has real coefficients, that has a root, one root that is x is 3 minus 4i. So in other words, I know one solution looks like this. Z is equal to 3 minus 4i. Now they've told us that the equation has real coefficients. Because it's got real coefficients, then every complex solution must have a conjugate pair that goes with it. So in other words, I've got another solution, and that other solution is that Z conjugate must equal 3 plus 4i. So if those are two solutions that I've got to this equation, then I can take this back a bit. I can say Z minus 3 minus 4i equals 0, or Z minus 3 plus 4i must equal 0. And if I go and multiply those two together now, I'm going to get something that looks like this. Z minus 3 minus 4i multiplied by Z minus 3 plus 4i, bracket around that, is going to equal 0. If I go and expand this just using the normal FOIL method that you're used to, it's going to get a bit messy. So a bit of a trick here that we're going to use. I'm going to remove these brackets and I'm going to put a new set of brackets in. So I'm going to start off, remove the bracket, and then I'm going to bracket these two things together, Z minus 3. And I'm going to be left here with plus 4i. And in the second bracket, again, I'm going to do the same thing, Z minus 3. And I'm going to be left with minus 4i. Now, hopefully you'll see that what I've done in doing that is I have created a difference of square situation. I've got the same initial term at the front of the bracket and at the back of the bracket. The only difference is between them, I've got a plus and a minus sign. Sorry. So what do I have here? It means I'm going to square the first part. So it's going to be Z minus 3 all squared minus, I'm going to square the second part, 4i all squared. And that's going to equal 0. And if I expand this out now, I'm going to have Z squared minus 6Z plus 9. 4i squared is going to give me plus 16i squared. I'll just do it in red over here because it's what's happening in our head. 16i squared. I squared is minus 1. So instead of having minus 16i squared, I could say that I've got plus 16. And so now I have my equation. It's going to be Z squared minus 6Z plus 25 equals 0. There is the equation that will have 3 minus 4i as its root, as one of its roots. The next example looks fairly similar to this. We're going to work with conjugate pairs because we've got an equation and clearly the coefficients of all the terms are real numbers. And you're told that 1 plus 2i is a root of the problem. So I know that Z is equal to 1 plus 2i, which means I've got another solution that says Z is equal to 1 minus 2i because those are a conjugate pair. So I can take these back a step and I can say Z minus 1 plus 2i equals 0, and Z minus 1 minus 2i equals 0. And if I multiply those two together, I'm going to get this statement. Z minus 1 in brackets minus 2i, and multiplied by z minus 1 in brackets plus 2i. That's a really useful construct to have, because I'm now going to get z minus 1 all squared minus 2i squared equals 0, in which case I've got z squared minus 2z plus 1 plus 4 equals 0. In other words, z squared minus 2z plus 5 equals 0. That would be the equation that gave me those two roots. But I know that those are two solutions, so in other words, I've got two factors there. And in other words, z squared minus 2z plus 5 is a factor of the equation for z cubed minus 11z squared plus 26z minus 15. So I can now work out what's missing, what my missing factor is going to be over here. I've got a z squared already. If I'm going to make a 4z cubed, I must have 4z over here. If I'm going to make minus 15, I've already got a factor of 5, so this has to be minus 3. And there I've got my final root. And so I can now work out I now have the three roots for this particular equation. In other words, my equation could have been written like this: 4z cubed minus 11x squared plus 26z minus 15 could be written as z minus 1 plus 2i, z minus 1 minus 2i, and 4z minus 3. So the roots that I have here is that z is going to equal 1 plus 2i, or z is going to equal 1 minus 2i, or z is going to equal 3 over 4. When you have one complex root within a cubic, you know that you must get a second complex root and one real root. So there's conjugates working within a cubic equation. And that's all we'll work for in this exercise. Goodbye.